Thanks, guys. All right, so past the first slide. Who am I? I'm Tony Germaneri. Everybody's heard that plenty. I have been working on browsers since browsers were first created, so that kind of sets my age a little bit. I love making UXs in browsers that just look like desktop apps. I hate web pages, and so I just want to see like WinForms inside of web pages. I love the W3C standards. I think that's my framework. That's just like the best thing that ever happened to a browser is what the W3C does and what they continue to do. I think that's the future of all web. And I love web components because the W3C made them, and I think in the future we won't have so many confusing web frameworks. We'll just have web components and things that build on web components encapsulated into web components. And in my free time, I play music and put it to js.la shaders and do all these crazy visuals. So if anybody's into that, please let me know. So tonight we'll talk about algorithm complexity. And this is, when I first started getting into engineering, this is something that just like, I had no idea what they were talking about. People would come up and they'd say big O notation, and what does that mean? Like, you have to know what big O notation is. And in JavaScript, you're even further removed from computer science because you're in this weird, loosely typed, coercive language where things just sort of work the way they're supposed to work, and you get abstracted libraries that just sort of do what they're supposed to do. And you start making this stuff, and it starts going slow, and you don't know exactly why. And so what we're going to talk about is why stuff goes slow and what the meaning behind that is. How did you make your code actually go slow? And why I ran into this, because I had a requirement at some point where I had a client who wanted to display a lot of rows of data, and they didn't want to have paging, and they didn't want to have it load up as it loaded. And so as the presenter said earlier, how do you get 10 million DOM nodes? That just will nuke your browser. You can't. It will nuke your browser. It totally doesn't work. And so how do you do it? There's a way to do it. And first I want to talk about the problems that I encountered when I was trying to get there, which is like all of the browser freezing and what that means. So I'm going to look at the different types of algorithm complexity real quick, and I'll just go right through this so you guys know what means, because I'm going to translate it into JavaScript. So this one is pretty straightforward. ON, it just means for each item inside of the array, you're going to do it one time. So N is the number of items, O is the number of operations, it's just straight one-to-one. In this list, I have an array of, I don't know how many things, but you can see it's just going to go through the list and it's going to be done. So as I increase the size of this list, the amount of time that it takes to go through the list is going to increase linearly. This is ON2. So you can see I've taken a loop and I put the same loop inside of it. So it's just going to be the same loop squared. You can see it running there. It's just going to be loop 1 inside of loop 2. And this is a really simple comparison function to see if there's any duplicates inside of an array. So this is JavaScript. It's something that people might run. I want to see if this array has 2 of the same thing inside of it. And it will kind of do it. But more importantly, it talks about what ON2 actually means. It's a loop inside of itself, and you end up squaring the number of records that you create. I'm not going to go into ON3, ON4, because it's kind of obvious. You just stick another loop inside of that, another loop inside of it, you cube it, you quad it, and it will keep on growing, and it will grow exponentially. This is another one. This is probably the most common search one. It's called ologin, which means every time you double the size of the array, the number of iterations that has to go through to get done with the array is only going to be one more iteration. So basically, this is called a binary search tree. If you're ever taking CS courses, they tell you all about binary search trees. And what it basically is an ordered list. And imagine you had an ordered list of numbers that just went from 1 to 1,000,000, and somebody said, okay, can you find this particular number? You could keep chopping the list in half and saying, okay, is the number higher or lower? And each time you do it, you would chop the list in half. And so that ologin one is actually a really efficient algorithm. If you have a very large set of things and you want to search through it, ologin is usually what you're dealing with. If you look at the native search or filter or any kind of functions like that inside of JavaScript, they do stuff that's under the hood, really deep in like a C++ language. You don't really know what they're doing, but they're doing an ologin, or they're doing it wrong. Like this is the efficient search algorithm. Now O1 O1's my favorite. Now, if you could do everything O1, you don't need to worry about speed inside of a program. O1's what's called a constant time algorithm. So no matter how many items are inside of this array, it always only takes one operation to get to it. And you do it all the time when you're in JavaScript. You don't really know, like, oh, I'm doing this really awesome this O1 algorithm. All you're doing is looking up a key inside of an object, or you're looking up an index number inside of an array. Whenever you do that inside of JavaScript, under the hood, the lower level C++ language, or whatever the browser's compiled in, it will actually equate it to something called a hash map, which is an O-log1 algorithm. That means that if you had 1 million items, or 10 million items, like the title of the talk, if I had that many items inside of this array, the number of operations it would take to locate and tell me the value of a particular item in the array is only one operation, which is really huge when you have a lot of items. And it takes a lot of time to deal with that. So here's a chart of the 4 most basic algorithm complexities visualized. So the JavaScript I showed you earlier doesn't really illustrate how badly an event can get based on the number of records. This kind of does. So you can see a linear, which was that very first one where it just loops through the records one time. It will progress at a pretty predictable rate. Exponential, that's the O2n, that's going to increase very quickly. An O2n would be like a Fibonacci sequence, something that it's very rarely encountered. Each time you iterate through the records, the number of records that you have to iterate through again doubles, or triples, or increases by a great number. It increases exponentially. So as you add records to that algorithm, it's going to go slower and slower and slower. When I say slower, it goes from half a second to 75 seconds to 3,000 seconds, and then you're just like off the chart. It's incredibly slow and you can't deal with it. Where if you have the logarithmic one, which is that every search is like this kind of algorithm, you can see the more items you add, it really doesn't increase the amount of time that it takes to do that. Constant time is the best. You can see that green line down there at the bottom. It is always super fast. And if you've ever used JavaScript and you've used an object, you don't measure the time that you do object refinement on objects because it just happens so quickly. It doesn't even seem like it's an algorithm, but it actually is an algorithm, and you could use that speed to your advantage. So what does all that mean to you as a web programmer? JavaScript is a single-threaded language, and what that means is when you do something in JavaScript, nobody else can do anything on the web browser, including the web browser's own internal code. It's just unable to operate on the same thread while you're doing something. And so you have to give up the thread, that main thread, every once in a while, so the browser could actually redraw the UI. And if you fail to give up that thread, everybody's experienced this. You've gone to name your favorite news site, and you turn it on, and the thing starts to load, and it just freezes. And you can't select text, it just freezes because I don't know what's going on. JavaScript is running, it's going through one of these algorithms that's obviously not an O1 algorithm. It's taken a very long time to loop through all of its things, and it's frozen the main thread. That freezing can happen without you even being aware of it. So maybe you've used jQuery before, and you've used like a selector algorithm or something. When you look at it, it looks kind of like an O1 because it says $, go get this particular thing. But if you actually look at what it's doing, it's going to go through all of the items inside of the DOM. And that takes a long time. There's caching and stuff involved in it, and after you do it more than one time, or after it's begun to initialize its objects, it may be O1 later on, but it will have to go through an ON or ON2 or one of these long algorithms. So even though you're abstracted from that and it looks like you're running what appears to be simple code, you're actually running through these really complex algorithms to go do something. So if it looks like when I run this one function, everything seems to freeze up, you might consider that maybe you're running an ON2 algorithm in there over a bunch of DOM nodes, and that's why it's going slow. It's really critical to know how your functions operate, because maybe you're starting out with just a few DOM nodes and you don't know how that's going to operate when you scale up. So maybe you have like a dashboard of all of the users inside of your system, and it worked great with 100 users, but as more users were added to it, it started going slower and slower, and you don't know why, and it happened to be this one weird click function, and you were looping through everything 10 times. And so you may not know that you're causing it to go slow, but any kind of JavaScript running will actually freeze the entire world. That may only become evident when you actually have a lot of scale or a lot of JavaScript running on a page. And that's kind of what happens to those news sites. Like you go on the news site and you're like, how did these people write this code where this is okay? Like it just sucks, this just sucks. And those individual guys probably didn't write code that sucked. They probably wrote code that ran just fine inside of their test environment. But when they started adding it to all of the other people's code, you ended up with these big synchronous blocking events where this guy's code ran and initialized, and it takes half a second, and before the browser could even refresh its UI, it started running another half-second event, another half-second event, and by the time it gets to draw the UI, it's been 3 seconds, and everybody's going like, why can't I click on this stupid web page? It doesn't work at all. And it's not that it's not working, it's just that there's gobs and gobs of JavaScript running, which may only be like 5 lines of code, but because of the complexity of the algorithm and the number of items that it has to loop through, it starts really going slow. And people are like, well, why do we have computers that do this stupid crap in 2018? And it's because we have these old processors, and the old processors are built up from old technology. And we have the dichotomy of processors and threads and security environments that things have to run in, and everybody has to play inside of this playground to run their code. And so JavaScript came along, it's a single threaded thing. It could only use one of these threads to execute, and this is the world that we're handed. It may be 2018 and our processors may be able to do amazing fast things, but it doesn't matter at all if we only have one thread to do them on. And there's some things that you could do inside of JavaScript to mitigate that, but for the most part, in JavaScript, you're kind of stuck with one thread unless you want to get extremely complex and start using things like web workers, which are kind of like multi-threaded JavaScript, but not really, really multi-threaded. But I'm not going to go into web workers. I think that they're wonderful because the W3C made them, and everything they make is wonderful. But they're a great way to, if you really, really need to crunch a lot of stuff, and you know that you're going to occupy a lot of stuff on the main thread, and you know you could do it on the side, and it doesn't have to be on the main thread. Web workers are certainly something that you could look at. Everybody's seen this horrible thing. This is literally because JavaScript is running. The only reason this happens is because JavaScript is running. Usually it's because somebody has done something very, very silly with JavaScript. And I'd even say that a lot of the time it's because there's some uncontrolled loop that will never end, and the browser's just like, you should probably just give up. But in some cases, you just have a lot of stuff to do, you know, and you're telling the browser to do this stuff, and it times it. It says, how long has this script held on to the main thread? Chrome will actually belch out a warning if you've held on to the main thread for more than like 500 milliseconds, maybe even less than that. And it's a little warning pops up in the console that says, that took a long time, guy. Maybe you should consider not doing that because you're really ruining people's experiences. And if it takes more than, I think it's like, I don't know, 30 seconds, I think is when I see this thing pop up, that means that you've really, really done something to screw stuff up. And there's ways to get around it. And even if you're not doing anything, if you've done a lot of stuff and you're done, it might still freeze up because this language is a dynamically memory allocated language, which means JavaScript handles how it's going to allocate memory and where it's going to put its variables and stuff. And it also means when you're done with your variables, JavaScript has to go through and clean up all that stuff. That process is called garbage collection, and it happens after you're done freezing the world. It goes and looks and sees what you've left behind, all of those unassigned variables, divs that are not in the DOM, things that you've just left in memory, and it freezes the world on the main thread, which is super annoying, and it cleans up all of the stuff that you've done. So if you're dumping tons and tons of DOM, and then you're removing tons and tons of DOM, it's not free, and it's not done when you're done. It's actually waiting for that early generation or late generation garbage collection event. So it says like, I'm really out of memory and we gotta stop everything. And it will literally stop everything for seconds. If you've done a lot of work, it'll stop it for seconds where the user's going, click on stuff and nothing happens. I'm trying to select text and nothing happens. And if you wait too long, you'll get one of these lovely error messages. So I'm going to create a lot of data in a browser here in a second, and I just want to show you guys the little function I'm using to create data. So I have an array, and each item in the array is an object, and I'm assigning a value to 10 rows, or 10 columns rather. I don't want the data to grow too quickly in the example, so I'm just limiting it to 10 columns. But you could imagine people's tables don't just have 10 columns. They usually have an arbitrary number of columns, depending on what client you're working for, and then they have an even more arbitrary number of rows. But just for the example here, I'm going to keep it to 10. Okay, so I'm going to switch out here and go into my example application, which is super small and you can't read it. Okay, hopefully I could zoom in here. Okay, so what we're looking at here is two animations. It's really difficult to tell that there's two different types of animations. One type is a JavaScript animation. The JavaScript animation is having this box move back and forth. The other JavaScript animation is this clock. It's just ticking. We're looking at Unix time in milliseconds here. But there's another animation that's happening here that's not in JavaScript, and we'll see it will become evident here in a second, and that's the CSS animation. CSS animation does not occur on the main thread, and that's wonderful. That means that you should only ever use CSS animation always, because if you're using JavaScript animation, think about animation, what it does. Every millisecond, I move some stuff, right? That means every millisecond, I'm going to stop the world, tell all of the other JavaScript programs to stop operating so I can move this DOM object somewhere, where CSS is just always operating. Okay, so these buttons right here, what they'll do is they'll create the number of records that it says here. So this is 10 to the second power, so 10 times 10, and then there's 10 columns. So you can see it creates it so quickly that the timer can barely even tell. But as I move up here, you'll actually see it start to go slower. And I can't see my cool little animation here, so I'm going to zoom out a little so you can see the animation. But as I click on these things, you'll see as that goes slower, we'll start to see that animation at the top lag out here when I get up to a high enough number. So we're at 100 milliseconds. Here's 10 to the 8th power. Okay, is that 8th power? Yeah. So you can see it just stopped right there for a couple seconds. If you're doing this on your web page, your users are frozen. They can't do anything. But you saw the CSS animation just happily goes through all super smooth. But otherwise, the JavaScript stuff is completely frozen. I'm kind of afraid to click on 10.9 here. I think it'll freeze the computer. But let's see. Yeah, it takes a long time. It might freeze it. Yeah, okay. That's kind of what I expected. Okay, so you can see even the creation of records takes a very long time as you start to scale up. And we're looking at all of these ON algorithms. So we're seeing it go up in a linear way. So it's actually like not super dangerous. We're not doing any exponential stuff, but it still quickly reaches that limit. Okay, I'm going to create some tables here. So this table, it has 100 rows in it, and it took 11 milliseconds to create. So I'm generating the table and generating the data at the same time here. Okay, that's 10 to the 4th power, so now we're getting up to, looks like 10,000 rows. It's starting to go, it takes about a second to go in there, but you can see everything is kind of sluggish now. If I get back up to my animation here, how do I get back up to my animation? I'll see the animation as I scroll around here. I can't even zoom out anymore. The thing is completely tanked. As I move around the table set here, you can see the JavaScript execution at the top is starting to go very slow. You can see it's actually frozen right now. I can't do anything. And that's because I've created so many DOM nodes. And there it goes. So you can see even when you're not doing anything with the JavaScript, just because you've created so many DOM nodes, what you're actually doing to the browser under the hood is anytime you move your mouse, what is the browser listening for? Mouse move events, mouse over events, mouse whatever events. Just because you move your keyboard, same thing. What field did they focus on? Now under the hood, they do a lot of optimization, but at the end of the day, there's those DOM nodes there, and it has to go through all of those DOM nodes. So when you move your mouse around, it says for every pixel, did I hit one of those 10,000 DOM nodes? And you can see that gets quickly crazy. It's already going slow. It's just not going to work out. So how do you deal with that? that freezing of things. We can already see that the sample data took some time to build. That's not normal in anything but a test environment, so you have to excuse the extra second or two that it takes for the data to be generated. Normally, your data set's already there. Either it's through an XHR request or it's on the page already. You're not generating it through some function that says assign. But besides that, you still have to deal with the large data sets. And when you use DOM in a one-to-one way, meaning I have a record or I have a cell and I'm going to make a cell out of that thing, you're going to lose as soon as you hit that like 10,000-ish limit. It's like 10,000 times 10 because I have the 10 columns, right? But you're gonna run into that limit pretty quickly. And even as you approach that limit, remember you're dealing with other people in the browser, it's gonna start going slow and it's not gonna work out. That's just a lot of DOM nodes. Now, if you had a lot of stuff, like I had a problem in the past where we had these weird file formats called BIFs, and they were actually a whole bunch of, I think they were GIF images or JPEGs, and it was weird because it was just a binary file, and they were just concatenated JPEGs, and they didn't want to have to download 20,000 JPEGs. It was for, if you've ever been to Netflix and you see the little bar across the bottom where you can see the preview of the pictures, those are the BIF format, right? And so they come down as a single file, and then JavaScript parses it, which if you've ever parsed binary stuff with JavaScript, you just want to shoot yourself in the head. It's a horrible, horrible thing to do. But it gets done super slow, and if you have 10,000 images in a movie to do, you're gonna tell the browser to stop because you gotta do the images, right? You gotta parse those images into other images, but you don't want to make the user experience bad where it's like freezing up the browser. And so one of the tricks that you could use is to inject request animation frame or inject set timeout into your looping lists. Now, if I just say that, you're like, you can't do that. That's crazy. You know, it's a loop. So there's these cool libraries like async that will help you inject set timeouts and inject request animation frame into your loop, like async queue or async cargo will allow you to give me 10 of those things and then set timeout for 2 milliseconds. And what that does is it does a bunch of work, it freezes up the browser for maybe 10 milliseconds, and then it releases it. And it says, okay, browser, go do what you need to do. And for the user experience, what that actually does is it makes it so it's not frozen at all. So your work is happening, but it happens in little bursts. 10, 10, 10, 10, 10, 10, 10. And by the time they need it, you know, when they're moving down over the thing, it's already done. We just didn't freeze the world to get it happening. That's obviously much slower than if we had just frozen the world and crunched all the images out. But the user experience is horrible because it freezes the browser for that number of seconds, and they just want to quit. They don't care about the images anymore, and that's the end. Okay, so in order to deal with this problem of, and this is just my solution. I'm sorry, this is not just my solution. This was a solution that I actually saw D3 and Google Sheets both use, which is if you want to make a lot of elements, don't make the elements at all. Just make one element. And so I made this little library. And if anybody's interested in the library, you could come and talk to me afterwards. I'm not trying to promote it. But what it does is it takes all of those records and it shoves them into a canvas. So I'm looking at a canvas here. This is actually just one element. And see, I have the, what is that, 10,000. So I have 10,000 rows. You can see the 10,000 rows inside of a single DOM element reacted much nicer than the 10,000 rows inside of the DOM. And also notice that when I assign data or I move stuff around, because of careful use of O1 algorithms, none of this freezes anything. So I could go and access all of the data all the way up to 10,000. I could select things, copy stuff. And you'll notice the animations at the top are slightly affected, but it's those same techniques I was telling you about. If you got a lot of stuff to work with, interleave it, do it in bursts and stuff like that. So I could deal with very large record sets. I've broken this little example up into 2 pieces so you can see how long it takes the record sets to be generated and then how long it takes to set the record sets. So I think that's 1 million there. And so that's this should be a million rows here. So if I'm just going to grab the scroll bar. It's going to take too long to scroll through that. But you can see the number down there. It totally says 1 million. I could do 10. I think it might crash it because of the other stuff I had going on there. But the important part is that I can get all of the data on there, and by judicious use of algorithm complexity, I can make sure that the browser never freezes. And so there's really no limit to how complex you could make your stuff if you make sure that you don't use slow algorithms, and you have to make sure that you don't use slow algorithms abstracted too. So even if you say you're using Vue or something, and Vue has this cool plugin for a grid, and the grid says it could do a whole bunch of cool stuff, and you do it, and it's just a single line that you did, and you injected it, but under the hood, it's doing all these O in 2 algorithms, and it's going super slow, and it just goes slow. You can't do anything about it. So this is one way to get around the limitations of having too much DOM. But algorithm complexity is not just to do with number of items inside of your DOM. It really has to do with all of computer science, not in just JavaScript, but across all languages. And I even think it's useful in real life too. If you say you walk into a car lot and you're like, I'm going to check each one of these cars. No, that's a O-N. Like maybe you shouldn't do that. So maybe you need to go O1, find the car that you want. I want this car, and then you can go right to that car, and it takes you vastly less time. So using these big O notation in real life is actually possible, and it applies to more than just JavaScript. And I think that's it. So does anybody have any questions about big O algorithm or? Thanks. Yeah, go ahead.
Yes.
So you're going to use a canvas to avoid all the DOM nodes.
Yeah.
Is the canvas using multiple threads? Like, what about the canvas?
Yeah, the thread, the canvas.
What? Yeah.
Oh, so he asked, why is the canvas fast if I'm putting all that stuff inside of the canvas? And the answer is that the canvas uses something different than DOM. DOM uses a drawing system where when you draw a DOM node, it keeps a reference to the DOM node, and it has events, then you can go back and reference it. Canvas does something that's called immediate mode drawing, which is when you put that pixel down on the canvas, it forgot you put the pixel down as soon as you put it down. And so there's no memory held up about it. And so I can draw that canvas depending on the speed of your processor, maybe 1,000 times a second, and display the number of records that you saw. So at any one time, you're only looking at like 80, maybe 100 records, and I only touch 100 records, even though the record set's huge. Judicious use of that O1, meaning like when I look at the record set, I only say this exact index. If I was ever to say, what about the whole record set? The whole thing would just break. And it took months of the whole thing just breaking to get to the point where there was only O1 algorithms touching the large record sets. So, okay, but what's up?
Yeah, one more.
Oh, just one more? Okay.
Yeah, we're gonna keep it moving.
Whoever wants to speak first.
Yeah, I saw you on the campus, you draw and select stuff. How do you do that on campus?
How do you drag and select stuff on a canvas?
How do you drag and select stuff on a canvas? You write a lot of JavaScript. a lot of JavaScript is what goes into making the canvas do these weird things that it does. It's a whole library that is dedicated to drawing data sets into a canvas. If you want to talk about the canvas after the presentation, I'm super into it, and I'd love any open source contributions, but I don't want to try to sell the canvas. I'm trying to focus on how algorithm complexity can ruin your entire day.
Are you going to be able to come to drinks?
Pardon?
Drinks after the event?
Oh, sure, yeah.
Yeah. So you should come to drinks, and you can talk to them even more about it.
Yeah.
Right?
I'll be super honest about algorithms.
No, I mean, this stuff is great. And yeah, you can see it right there. The CSS animation runs nice and smooth, and all the JavaScript stuff gets junky. But yeah, there's a lot of solutions out there now for this kind of stuff, and it's becoming more and
like
more
I said,
common.
Sheets does the same thing. Google Sheets uses Canvas also.
All right, you're gonna make what? What do you want? What do you want to know, Laura?
Another question.
Yeah.
What are some things we could do as developers, like for using tools to use JavaScript frameworks to evaluate what algorithms are happening at a physical side in the source code, looking for those loops? Like,
Yeah, that's a great question.
like a dev tool or something like that?
Yeah, so the question was, how do we determine which algorithms are going slow? What am I running? Like I said, don't run that stuff abstracted. You don't get it for free, even if it's abstracted. The best bestest tool ever is the Chrome Profiler. You hit record and you do your stuff and you go look at the flame graphs, and the taller the flames, or I guess the wider the flames, the more screwed up your code is. And you could go into your debugger after that point, and it will tell you line by line how long each line of code takes to execute. As far as figuring out what the complexity of the algorithm is, you probably just have to email somebody that knows about code complexity. I'll take the questions if you have one. But you're basically counting the number of loops inside of loops and then making a formula out of it.
All right, give it up for Tony. That was great.